The broadcast is now starting. All attendees are in listen-only mode.
الو السلام عليكم. بسم الله الرحمن الرحيم. انا احمد ابراهيم من اي بي ام اكزيكتيف اركيتكت. طبعا الاول احب اشكر كل اللي حضر الويبينار النهارده. Now we will talk in English, but يعني in a way we will mix between English and Arabic if necessary. Today we will be talking about Internet of Things, specifically about designing an IoT-based AI application on cloud. That means we will be discussing the difference between what are the steps that we need to take to identify the solution, how we tackle the problem. But before that, we will be talking about the IoT technology status and trends by 2018. Mainly, that's because by the end of this year, we will have some of the trends identified already, and we will be discussing these trends. Then we will be discussing the problem the problem domain, the problem context that we are going to solve, which is a technical problem. It's an industrial problem. Just a minute. I'm seeing there is a technical problem or something. I think now the problem is solved. So let's start from the beginning, just in case those who missed it. So we will be talking about this is the agenda. So we will be talking about first the technology status, the IoT technology status, and the trends of by the end of 2018. Then we will discuss or explain the problem that we are going to solve. It's an industrial problem, and we will try to explore the different aspects of it. Then the next steps will be mainly identifying how to solve the problem, starting from preparing your method to tackle the problem, identify reference architectures so you can follow. Then you build your design, and finally you identify the different alternatives for the architecture decision that you are going to take. So we will start by the trends. So this is a diagram that shows the number of connected devices in 2000 or prediction for the internet connected devices till 2025. It's by the end of 2017, the expectations or the estimations for the connected devices was about 20 billion, 20.345 billion connected devices. That gives us, if we calculate or identify the number of connected users using the internet, that gives us 6 devices per user, internet user by end of 2017. 6 devices per user. Right now, by the end of 2017, which is the time of calculations, if you can see the if you can identify in the 2025, the expected number of connected users will be like triple times, more than triple times. That means we are expecting like 18 devices per internet user. which is a huge number of users actually. So given that number and the expected growth of the IoT technology, that's also we need to identify the trends of the technology itself. So the first thing is about fragmentation in standards. And communication. So the industry leaders like Qualcomm are taking the lead against fragmentation to provide an open standard through Open Connectivity Foundation. This is a foundation that's handling the different standards to standardize the IoT standards like protocols and so on. The foundation is dedicated to providing the key interoperability elements of IoT solutions and aims to develop standards, promote interoperability guidelines, and provide a certification program for IoT devices. That's mainly all efforts towards standardize or unify the standards across the different standard industries, as well as the different communications and protocols. However, the expected trend is that the fragmentation or the differentiation between the different standards will continue to grow. And that's mainly because the different players or the different stakeholders in the industry is still working separately and focusing on different agendas, if we can say that, to identify or to tackle the broad market and to gain the market share, because we're still on the beginning. So the expectation is that we still continue in this fragmentation. The fragmentation also, or the growth also in the more connectivity and more devices, more and more devices. You can see that the growth that we just show in the previous slide, it shows that there will be a huge or exponential growth of the connected devices. We still the fragmentation of the standards and the communication will definitely add major challenges on security. However, there is still there is now a hope in using blockchain as a paradigm or a technology for applying security on and applying transactional secure transactional system across the different devices, which will reduce cost and doing away with the need to trust central data sources. So with this hope, however, until it's mature and we finalize it, or we reach a fair technology, we can say that we have huge security challenges in the next year. Still, the IoT investment will continue. There is IDC predict that spending on IoT will reach nearly $1.4 trillion in 2021. Of course, that's that investment in different aspects of IoT, like hardware, software, services, connectivity. So almost every industry will be affected by IoT, which means many companies will benefit from its rapid growth. So, and of course, if you are a player or a player in this market, and you can identify the huge opportunities of the market with this huge spending. Then we see also that there is a trend for what we call it fog computing will be more visible. Here in this forum, in the IoT Egyptian forum with ITIDA, there was another webinar explaining the fog computing. The fog computing is mainly about smart fog nodes. the fog computing allows computing, decision making, and action taking to happen via IoT devices themselves. So the devices, the IoT devices, if they are smart and they are equipped with the needed processing power, then we can call them as smart fog nodes. So, fog computing gave a brilliant definition. The fog extends the cloud to be closer to the things that produce and act on IoT data, and of course, it takes or distribute the processing power on these smart nodes. So the load on the data and the huge data is distributed, and only identified results will be sent to the centralized processing data. So again, any device with computing, storage, and network connectivity can be what we call it fog node. Then there is a synergy expected synergy between the IoT technology with the augmented reality, like Zapper framework or Zapper augmented reality platform, which cooperates with everything to fold interactivity into an everyday application of smart devices. Also, with artificial intelligence, AI, like the image recognition, for example, the machine learning for predictive maintenance. So these are expected to consume the technology of IoT. So IoT is providing these technologies with the needed huge or big data that they need to build the models and to build understanding and to work more actively to identify different problems, or to identify, recognize faces or whatever. And that's coming from the IoT technology itself. Then we are expecting that there are a big need for skills in IoT, especially in the big data analytics. That's a good news for all developers or all workers in the field of the IoT, as the dynamic sharing is at the heart of the IoT, and big data analytics will be instrumental in building responsive applications. So integrating IoT data channels with AI to retrieve on-demand analytics insights has already gained momentum this year, and will definitely grow exponentially in 2019. So if you are not ready yet for this, we still have a chance to move on to gain more skills in the big data analytics and the AI. If you start moving, then you have a better chance. It's coming on. So let's start with the problem context. So what's the problem we are talking about that we are trying to solve? So we are targeting to build a solution or a framework for what we call it Industry 4, or Smart Factory. So what's the Industry 4? Industry 4 is a name given to the current trend of automation and data exchange in manufacturing technologies. So we are talking mainly about manufacturing technologies. It includes cyber physical systems. So the connected systems in the factory, they are calling it cyber physical systems. The Internet of Things, of course, cloud computing, and cognitive computing, or the AI. So Industry 4 is commonly referred to as the fourth industrial revolution. So if we can see here, this is the first industrial revolution. It was in the 18th century. Then in the second one, with when we had the mass production assembly line. And the third one, mainly when we had computer and automation for the industry lines. And this is the Industry 4, or the fourth industrial revolution, when we have cyber physical systems interacting or working, interacting or communicating together. So that's about what we call it the industry 4. Uh, Also, the concept of the smart factory is mainly the merging of the virtual and physical world through cyber physical systems. So how we merge virtual and physical worlds there. It's mainly we use the what we call it a concept for a digital twin. We are going to talk about it a bit in a second. So and the resulting fusion of technical process and business processes are leading the way to a new industrial age. This defined by the smart factory concept. If we have a look at this diagram here, we are talking about mainly different factories that are connected to the enterprise. So each one of these factories is having multiple machines. They are talking with the machine-to-machine communication, and they are expected to be smart machines. And they are working on an application platform for the machines communication itself. And we call it again the cyber physical production systems. That's mainly handling smart materials and expected to generate smart products, of course. So that's communicating or depending on the secure cloud networks. So that's what we call it as a concept is the smart factory. Uh, so what are the different design principles when we start thinking about implementation for this solution or this problem domain, which is the manufacturing? How we are tackle or what's the design principles identified in the industry 4? Um, so the main design principles are four: interconnections, information transparency, technical assistance, decentralized decisions. And what that means? Of course, the interconnection is mainly the interconnection between things like the machines, devices, sensors, and people. So they are talking about IoT, Internet of Things, and IP, Internet of People. Um, the second principle is mainly the information transparency, so to make appropriate decisions. So all the information across the whole process of the manufacturing process is tracked and identified and collected, so and shared with the machines and with people. So the information transparency is full, and that's provide the decision makers the ability to take the appropriate decisions. The third one is the technical assistance, and mainly what we talk about the technical assistance here is two things: visualizing the information for the systems, as well as physically support humans. So to give you an example, if there is a need to track the heat overheating for a machine, you can have two things. You can have a dashboard that's indicating, giving an indication with the high temperature for you. Or the other thing is that there is an automatic cooling actions that's physically done for the machine without waiting for the interference of human interference. So that's the technical assistance, what we call it technical assistance, visually and physically. Finally, the fourth one is the decentralized decisions. So each machine is actually smart machine enough to have the ability to make decisions on their own. That's again the same example for the overheating, and the machine takes the decision to make cooling decisions, for example. So that's on high level what's the industry for, what's the problem domain or the problem context that we are talking about. So what's the functional requirements we are talking about here, what we need to implement in our solution. In our solution, we need to have a vertical and horizontal integration. So vertically means with the different inputs and horizontally with the different systems, or extending the existing systems. The life cycle integration digital twin. So again, the digital twin is a real-time digital replica of a physical device. There was in this forum, there was a full presentation about the digital twin. If you return back to the previous recording, you will find a full, very good presentation about digital twin made by my colleague Ahmed Hassan in IBM. We are trying to tackle the life cycle integration, the integration across the life cycle of different machines, and the digital twin when we have a replica for the physical device with a digital device. Also, we need to have, in our solution, we need to have a universal connectivity between the processes, systems, machines, and people. So there is no, the maximum flexibility and the maximum platform, connectivity platform available to the factory. So there is no specific restrictions about connectivity. And of course, we need to have intelligent worker assistants, like, again, robots, for example. If we can have robots that's smart enough, we automate the work, or intelligent support, like, for example, having enough dashboards and predictive analytics or predictive maintenance, so we can predict whatever problems that we are expecting based on historical data. So these are all intelligent worker assistants that make the life easier for workers in the factory with the tension and under pressure. The fifth input is the historical data collection and predictive analytics, of course. So we need to collect all the data, historical data, and we have to maintain these data as a data lake, for example, and to have a predictive analytics, so we can predict whatever abnormalities and problems that we are expecting. Finally, we need our solution to have a flexible and business-oriented configuration at all levels. So mainly including shop floor. Shop floor is mainly a term in the industrial, it's an industrial term talking about work in the plant itself or the factory. Of course, we are talking about the integration, so flexibility in the integration, and the age. So the age itself, the connectivity of the age gateways, for example, is the flexibility to control that. So that's another functional requirement. Of course, there are some business challenges that we will be facing. And we will try to tackle them. Mainly the business challenges is like productivity gains. So the higher throughput and efficiency and eliminating non-value adding activities. Non-value adding activities mainly when we have automated processes and they are almost legacy processes, and these legacy processes having redundant activities or steps in the middle that's not really adding value, and we need to eliminate them. And to do that, we need to have the right monitoring on the right activities in the system, activity monitoring in the system, so we can identify which step or which activity is not really meaningful for what we have. Also, another business challenge is the failure prevention. This is a business challenge. The target is to maximize the overall equipment effectiveness, or OEE. Overall equipment effectiveness is mainly when we we compare the lifetime of the equipment versus the output of the equipment and the cost of running maintenance. We need to maximize that, and we also need to minimize the downtime for the different equipments, which is the predictive analytics. Also avoiding rework. Of course, you don't need to have a redundant rework and cost for that. The outages for the equipments and the poor product quality in the final stage. So these are all failures and different stages that we need to prevent. Finally, we need to have flexibility and hiding the complexity, like for the configuration of reconfiguration efforts. There are a lot of configurations. Specifically, we are talking about fine-tuning devices and equipments. So we need to hide such complexity, and we need to enable the plug and produce, and avoiding the different technology gaps, especially with the fragmentation that we have, as explained in the trends. So I think by now we can say that we understand the problem. So the problem is mainly to build a solution to provide the ability in the Industry 4 era to automate the different to automate a factory and to move the factory to be a smart factory. So how we can design such a solution, or how we can provide such a solution. There are different aspects we need to tackle in such solution. But before we go into the technicalities for that, we need to identify the way to do that, or what's the method you are going to use to follow. So the method, or the architecture method, as I refer it, is mainly guidelines, a set of best practices and guidelines in different domains that you need to follow, and make sure that these best practices are applied in your solution. So there is no need to have to follow one method. You can follow multiple methods. So, for example, one of the methods that we identified here is the IBM Cloud Garage method. And I will show you a quick introduction for it. These are the different aspects. So we are talking about, we start learn, discover, invasion, build, run, and manage. And these are all about the differentiation with the culture. So these are the way to handle in a way the thinking, and also finding the solution, your solution. There are details in the IBM Cloud Garage method, and there is a link provided in the references. You will find that. There is another methodology here. It's called the 12-factor app methodology. And the 12-factor methodology is a methodology for building a software as a service applications, or on the cloud, which is completely delivered as a service right now, like the web applications. So the main thing here is to follow these are 12 factors, 12 practices. You need to make sure that they are applied in your application, or some of them if possible. And again, the 12 factors, the link to the 12 factors is available in the references. But you shouldn't, it's not only one way, or a mix, how we can go, which one. There are others, of course, other methods. There are methods could be imposed by the customer himself. So, for example, the customer, if it's in the manufacturing industry, they have standards, they have methodologies, they created their own methodologies that you need to cope with. So you will need to take all of these methodologies and create your own methodology. And of course, that's the methodology that you will be following. Okay, so this is the methodology. The next step after the methodology, so you identify your plan. The method is helping you to identify your plan. The next step is to identify a reference architecture. So what's the reference architecture? Reference architecture is a set of known patterns applied or identified for solving a specific problem. So in our case, in the manufacturing case, we have two aspects of the solution. One aspect is the IoT, and the other aspect is the AI. So first we will start with the IoT reference architecture, which is coming from the IBM reference architecture. I will stop the presentation here when we will go to the demo mode, and then we will come back again to the presentation. So this is the IBM Garage method. This is the different aspects and the different explanation for the different stages for it. Of course, you will have a lot of information there. I think we have some technical issue. So let me try to solve it first, so you will be able to see that. Okay. So I hope you are now able to see my screen. I was showing the different links to the Garage method, and I was saying that in this link or in this Garage you will find the different best practices and the different stages that you will need to follow, and more elaboration about that. So the other thing that I would like to share with you is that there is an architecture center on the IBM Cloud Garage. In this architecture center, this is mainly helping or providing reference architectures for building cloud-based applications for the different domains like infrastructure, like private cloud, public cloud, AI, data and analytics, microservices. So there are a huge number of reference architectures there. You will also there are a set of industry-based solutions like banking and financial, automotive, and so on. So you will find, I hope you will find a very good starting point from there, and then you can modify that based on your inputs. These reference architectures are from IBM perspective, but mainly it's more generic. So we will see specifically two of the reference architectures. One is for the Internet of Things reference architecture. So let me try to make it. I hope you can see it now. So this is the reference architecture for the IoT. That's mainly trying to give you a reference architecture or the best practices for overall IoT application, general IoT application, but this IoT application will be connected to the internet. So you have, in most of the cases, you have a device which contains sensors, actuators, of course, firmware plus network connection. Then you also have a gateway. So the gateway is, in a way, it could be a smart gateway, connected IoT devices, or it could be industrial gateways, as we will see later in our solution. Then we will have the edge services. The edge services is the entry point or the gateway to the to the cloud. You can have in this you provide a DNS, content delivery, and of course IBM Watson IoT. That's given. That's given in the reference architecture, which means that you, in a way, you will need to identify the gateway, the edge services for the gateway. And then you have the IoT transformation and connectivity. That's mainly trying to get this information and build and transform it into more into business information and translate that to the following layers. Um, I So I think the other thing here is that the other layer is mainly the devices registry and management. So device management is part of the IoT, and we are talking about existing on cloud, and of course device registry as well. And these things are having a back end of device identity services, so we can identify the connected devices. And of course, we need to provide an API management for the IoT solution, so we can connect with other IoT devices. And there is an application logic. That's your application logic. You have alternatives to build your application on cloud, either with Node.js, for example, or Liberty for Java as a WebSphere application server, or there are more alternatives for you to build your logic. And of course, what we need is the analytics. So analytics is different products. So you have you can have IBM Watson machine learning insights for Apache Hadoop, Watson APIs, Apache Spark, and streaming analytics. These are all provided from IBM. And of course, I understand these are also provided from other vendors. But again, as I'm explaining this, we are trying to put a general solution for you. Of course, you need to visualize your information, so you can have IBM Cognos and IBM SPSS for prediction, and you also can use Tableau for that. For the process management, you need to manage the process workflow itself, receiving information from the application logic, and invoking the process automation for the different aspects based on the information coming from the IoT. So you can use the IoT platform or the message hub, and of course you will need the device data store. That's different. It could be based on NoSQL database like IBM Cloudant. You can provide with data warehouse like the IBM DB2 warehouse. You can have IBM object storage. So you have the flexibility, but you will need to identify which data store that you need to use. And finally, you will have again the transformation and connectivity to the backend, to the systems for the second tier. So to the backend system like in the enterprise data, and the enterprise user directory itself. So and the enterprise application. So if we need to connect all of that, that means you will need to connect through the transformation and connectivity. So in a summary, you will have a users layer, you will have a productivity network, you will have a connectivity through a public network, and then into the producer cloud, the provider. And finally, from the provider, you will need to connect to the enterprise. So this is the overall architecture overview. And of course, across there are a lot of security handling for these different aspects, starting from the IoT security till the cloud security and the big data security. And also there are IoT governance provided on the cloud. So this one is the Internet of Things reference architecture. What about the AI? So there is an AI reference architecture as well. The AI, sorry, in the AI reference architecture, they are talking about three main services provided by the cloud. You can consume them, so it's not or types, not really services. There are a huge number of services provided on IBM Cloud, but there are three categories for that. So mainly the conversation, which enables creating virtual agents and chatbots. We have discovery, that's discover your data sources, all your data sources, and identify different information and categorize them and classify them. And of course, there is extended component that add value to the cognitive application, like speech to text, text to speech. These are the different services that we can use, like for example, visual recognition, personality insights, natural language classifier. We can use all of that to solve the different AI problems. Of course, of course, there is the input for it is coming from public APIs or the third-party APIs for different information, or the external data sources like the social media, like including the news, the documentation, the internal documentation. So these are all inputs for the different APIs or for the AI. And again, you will have a connectivity, a transformation connectivity to the backend system. So the user here, he is using different channels, and we are trying to simulate these channels on the other side. So we are providing support for him through assistance or visual assistance. We can use replicate all the social media on the other side. So this is mainly the AI reference architecture. What about our solution? So our solution is focusing here about the planet. So we are trying to solve our problem. So the industry for solution for these are the business challenges. So our solution is mainly divided into three parts. The edge part, this part is the providing all the connected devices through the OT, operational technology, and IT, the information technology gateway. So this gateway is mainly focusing on the intelligent hardware providing access to machines via field bus protocols. And that's mainly using the industrial product controller for IoT gateway, like Net IoT Edge, Cisco Edge, AdLink. So these are the different aspects. These are not IBM products, but we, as I mentioned, we are, because it's more into a generic reference architecture. It's trying to help you to identify the different third-party items here. In the IoT, we have role-based analytics. These role-based analytics trying to identify the data filtering and building a smart edge or smart or preparing for what we call it edge computing. So we try to identify or provide dynamic data filtering, statistical data, the aggregation, cleansing, and compression and preparation for further processing. So we take the load off from the internet or from the cloud provider, and we are using the huge number of the gateways provided on the different factories to do these different rule-based analytics. We can use the Node-RED. Node-RED is an open source technology mainly created by IBM and provided to the open source community. It's used for developing flow logic for the messages for the IoT. So these are the different aspects. We also have the edge data model, the edge data store. Of course, you can have IBM Informix, you can have Cisco Edge, Flash or time series, you can have IBM Edge Analytics SDK for storage. So this is to store the data coming from your connected data. And you will be using the information model in the edge. So the information model is mainly device independent data model. It could be coming from a standard model, like what we. So that's the analytic on the edge side. And there is also analytic on the planet side, or the factory itself. So we are receiving the data from the gateway, and then we are receiving it by using the Planet Service Bus. So the Planet Service Bus is mainly a way or a factory level integration layer. It could be a software or it could be a gateway. So it's mainly software. Its main mission here is providing routing, transformation, mediation, configuration, and workflow based on events, as well as delivering the base for in-factory microservices. So, of course, in the side talk, there is a debate about using a bus or a service bus pattern with the microservices versus the concept of microservices or of the smart node dump link. So, however, IBM positioning, there is no IBM is positioning the service bus here as a way to connect the different aspects, and there is no contradiction between using this and the microservices, because IBM believes that there will be a hybrid existence between services or SOA and microservices, and there is maybe with a greenfield or new technology or new clients, we may have full microservices. But right now, when we move on, we will continue to have such mixture. So this is mainly a gateway for providing connectivity, and this is using IBM Integration Bus manufacturing pack. We always have the decision that you need to tackle when we solve our solution here, mainly for the smart factory. What information will go through the cloud and what information will keep on premise? This is a debate that's mainly you will face in different cases, because of it depends on the sensitivity of the information flow. So, for example, I faced different aspects of this in the oil and gas, petroleum. So there is a huge restriction on the information to flow outside the planet or outside even the infrastructure of the vendor or for the customer. And there is versus on the other side, there is specific types of information that can flow to cloud. So as an architect or as a designer for the solution, you will need to discuss this with your stakeholders to identify which information should go to cloud and which we will maintain on premise. So based on that, you will be able to decide, for example, for the Planet Service Bus, which one we will be able to use. Are we going to use the one on-premise, like the Enterprise Service Bus, or the one on the cloud? Again, the IBM Integration Bus or IIB manufacturing package is available on cloud from IBM Cloud, or the IBM Watson IoT itself. So these are you will face these alternatives across all the domains in the different aspects of the solution. So let's focus on the rule-based, the analytics part, or the analytics components, different analytics component in the solution. So we discussed the age, the rule-based analytics. We also have the shop floor analytics. The shop floor analytics is mainly the in-factory insights. After we receive all the information coming from the IoT, we will need to build our insights, alerting system monitoring, our predictive analytics, like the predictive maintenance, for example. So this, which will need immediate required and applied to production systems. Again, we will have these products on premise and these products on cloud. We have SPSS for predictive analytics. That's mainly for building information, predictive models based on our historical data. We can use Spark machine learning or Python or our enterprise using our language. On the other side, we can use Watson Data Platform, which is based on Spark machine learning as well. We can use the SPSS predictive analytics enterprise on cloud. We can even use Cassandra, which is a database that's mainly designed for huge amount of data and huge dynamic information, Apache Cassandra. So these are alternatives for the shop floor analytics. In the other side, we still have, again, when we collect all the data from the different factories or from different planets, we need to have a high level or enterprise level analytics across such data. So we can have enterprise analytics for the cross-factory insights. And again, we can have either on-premise, and we can use still the same set of products, or the products coming from cloud. But that means you will need to have two different instances of such products. That means you will need to have an instance within the factory or instance per factory. Instance means not one instance service running. I mean existence, one logical node. And one logical node for the enterprise. Of course, there are connectivity coming from, when you will start the connection coming from the planet to the enterprise is done through the enterprise IoT hub. Again, it's IIB Bus Advanced Edition, or on the cloud itself. That's providing the data integration. The data integration is mainly the ETL based data. It's building or doing a cleansing, transformation, and storage, and like having one MDM, master data management, for example. These products can, this node can be used or implemented or realized, we call it realized, using the products from InfoSphere on-premise or Watson Data Platform on cloud. All the details for this solution, because we are running out of time, all the rest of the details for the solution is available on the link that's we are providing here. So to summarize that, I can say that we were able to identify alternatives and make decisions for different aspects like OT, IT gateway, the on-premise. The main issue is you need to tackle is which part is on-premise and which part is on cloud. We identify different technology on the gateway, for example, Node-RED versus Telet device-wise. These are two different technologies for transformation and connectivity on the gateway. We identified analytics-based insights and actions, different products to implement that, the shop floor workflow, and implementing this through IBM BPM, business process management, either on-prem or on cloud. The Planet Service Bus, as we mentioned, using the IIB with the manufacturing pack. Shop floor analytics, again, with the SPSS for predictive analytics and predictive maintenance. We can use analytics, Apache Cassandra. For the Planet of Enterprise Information, we need to identify which standard we will be using and versus. So the standard is that there is a given data model. In the standard you will need to adopt or to use, versus that there is a custom thing that it's not really standardized, then you need to build your own information model. So you need to take this such architecture decision, either to adapt a standard one or to go with a maybe lighter custom one. But we need to highlight very important thing is that you need to tackle the non-functional requirements, because I call it the hidden killers for our applications. In our cases, you need to be able to size the different data flows coming from the different devices into the gateway. You need to identify the different sizes. You need to identify the number of online machines and the connectivity across different aspects. So these are all non-functional requirements that you need to tackle. Maybe we can have another session about specific non-functional requirements for the IoT technology. These are the references that you will need you will find links to it, and I think it's the time for the questions. If we have any questions, it's the 1 hour sharp, so if we can have 1 or 2 questions. I'm checking, currently I'm checking the, okay. I'm checking the questions right now, so let's try to answer them. So what's the, there is one question about what's the fragmentation. The fragmentation is mainly the differentiation or inconsistency between the different standards. In other words, we are not really agreed upon one way to communicate with each other. So one vendor is tackling or creating a protocol, while the other vendor creating another protocol. It could be overlapped, it could not be overlapped. That's the fragmentation, having different bits of pieces around one solution. Another, could you please elaborate more about the smart materials? Well, I think smart materials is a term that they used for the factory, the smart factory. In this case, I'm not sure. Actually, I'm not sure about the term itself. But let me try to get the answer for you, and I will check for it. And I will try to put the answer on the YouTube when we publish the video. I will or by email. So I will try to contact you, Yasser. I will try to contact you with the email to provide such information. There is another request that we replay this session in Arabic. So yes, I have no problem with that. I actually I hope that we can do that for the Arab world. I prefer that you speak in Arabic. Well, how does the blockchain work? Well, we had in this webinar, we had one full session about the IoT and blockchain. I think you will need to it's a full 1 hour about the topic, and it was a very good session, so you'll have your answer there. What's the difference between edge and fog computing terminologies? Again, we had such a presentation for the fog and edge and the comparison between them. In a summary, the edge computing is mainly trying to build the capabilities on the edge, which is the gateway in our case. While the fog, which is a concept created by Cisco, is trying to put all, I mean, it's not really the gateway only, but all the devices that's having storage, connectivity, and processing power that's use these devices to help in the analyze and filter the data received by them. I hope this answers you, but on the other hand, there are a full session about this topic on the wiki for this forum. In this reference model available online, yes. When we publish the video, I will put an attachment or the links with the video on the YouTube for your reference. But yes, it's available online and for everybody. What is about the open source? Well, IBM is focusing on open source. I explained that different products, open source products is available. So open source is making a shift for IoT definitely. And I was thinking about making another webinar about the open source technologies and the impact of open source on the IoT. But I think there is another session about the open source on that's run already. But there is a huge impact for open source on the IoT, and there are a lot of open source alternatives that I went through some of them. Also, how do you see the future for this in Egypt? I mean, if you are talking about the open source alternatives or for the IoT, if it's open source, there are a huge base of users for the open source in Egypt, I think. And for the IoT in general, if we are talking about the IoT and the industry, it's a greenfield, and the different manufacturing players, they are in a way mature players, and they have money to spend. So as long as you have money, you have opportunity to do a better job. I mean by this industry 4, I think it's I missed the, yeah, okay. So so Sami, when you mentioned the future in Egypt, he meant by, I mean by this is the industry 4, IoT, AI, and so on. There is, I can expect a delay, but we will definitely go there. It's the trend, and by the time the delay is going shorter and shorter. So my expectation is that we will go there. We have as an IBM, we have vendors working in Egypt about that, and we are trying to apply it. It's a huge solution for industry IoT, and so I'm expecting for this to be really a good start. So I think that's it. There is no further questions. I'm sorry for being 7 minutes late, and thank you very much for your attendance. I think we will stop there, and soon you will have the recording for this session available for everybody. Thank you very much, and hope to see you soon.